In this video, we are going to study integral a squared plus minus u squared form. U represent here one function that depends to x, and we are going to solve this kind of questions by using the trigonometric substitutions. For that one, we need the right triangles also. Firstly, for this type of question, here the term a is equal to 1, so this is also 1 square, so 1 square minus x square, x is equal to u. And how to solve this type of questions? Firstly, we should try to understand. If I draw one right triangle here, and if I choose one of the angle 90 degree, how can I evaluate 1 minus x square in this right triangle? If I subtract, it means that this is one of the right side, it should be. So this is going to be the 1 minus x square, root of 1 minus x square. But if I use the Pythagorean theorem, so the hypotenuse, it should be 1, and the second side, it should be x. So 1 square minus x square, it's going to be the third side, root of 1 minus x square. And here the substitution is that we are going to do sine alpha, it should be equal to x over 1. Then sine alpha is equal to x. And if we differentiate both sides, the derivative of sine alpha is equal to cosine alpha. Cosine alpha d alpha is going to be equal to dx. Okay, I found the dx, but I need 1 minus x square, so this is equal to, this question is going to be equal to integral square root of 1 minus x square dx. Then it's going to be equal to, here, square root of 1 minus x square is equal to sine square alpha over, times cosine alpha d alpha, it's going to be. Then here 1 minus sine square alpha, it's going to be equal to integral square root of 1 minus sine square alpha is equal to cosine square alpha, it's going to be, times cosine alpha d alpha. Here this square and this square root, we are going to simplify, and we are going to get this expression here. It's equal to integral cosine alpha times cosine alpha d alpha, it's going to be, and this is integral cosine square alpha d alpha, it's going to be. If you remember, when we're doing this substitution for the cosine square or sine square, if there is cosine alpha and cosine alpha, sine alpha here, you may select one of them as u, then the other one is du, it will be. But here we have only cosine square alpha, so for the cosine square alpha, we are going to make this trigonometric substitution. It's going to be equal to 1 plus 2 times cosine alpha, cosine 2 alpha over 2 is our trigonometric substitution it's going to be, which means it is equal to integral 1 over 1 plus cosine 2 alpha over 2 d alpha is going to be, and the trigonometric of this one, integral of this one is equal to 1 plus 1 over 2 d alpha plus cosine alpha, integral cosine alpha, integral cosine 2 alpha over 2 d alpha is going to be. Okay, then it's going to be equal to 1 over 2 integral 1 over 2 d alpha can be written integral 1 over 2 integral d alpha. This is equal to alpha, 1 over 2 alpha, it's going to be 1 over 2 alpha plus c, of course it's going to be what we are going to wait for this one also, and this is equal to 1 over 2 cosine 2 alpha d alpha, it's going to be. And let me remind you about the integral of cosine. integral of cosine ax plus b, if you remember, dx, it was equal to 1 over a sine ax plus b plus c, it's going to be, and we shouldn't forget 1 over a here. So here it's going to be equal to 1 over 2 plus 1 over 2 times 1 over 2 sine 2 alpha plus c, it's going to be, okay, sine 2 alpha we found, it's equal to 1 over 2 alpha plus 1 over 4 sine 2 alpha plus c is the answer. But here the terms are not with x, that's why I need to convert them to the x form, and I'm going to do them here. Firstly, we know that sine alpha is equal to x. This means that alpha is equal to arc sine x. So we are going to do like that. And second one, sine 2 alpha, again this is trigonometric substitution, it's equal to 2 sine alpha times cosine alpha. So instead of this one, if I write one more time 1 over 2 alpha plus 1 over 4 2 sine alpha times cosine alpha plus c, if I write one more time, then this is going to be equal to 1 over 2 as alpha is equal to arc sine x plus this 2 and 4, when you simplify it's going to be equal to 1 over 2. Sine alpha is equal to x, cosine alpha is equal to cosine alpha here root 1 minus x squared over 1, which is equal to x times square root of 1 minus x squared, this is cosine alpha, plus c is the answer it's going to be. Now this is our second question, and this question also again we have to draw the right triangles. Here if I choose the angle alpha here, then one of the sides it's going to be 4x squared minus 1. This is when we have subtraction. Exactly we know that, exactly we know that one of the side it should be right side, it should be 4x squared minus 1. I'm choosing this one, 4x squared minus 1 in the square root. This is the right side, so one of the side it should be equal to 1, because 4x squared here the bigger term, it means that this is the hypotenuse it's going to be, and the hypotenuse it should be equal to 2x. Now if I do the substitution here, the easiest one now it seems to me, sine alpha is equal to 1 over 2 x it's going to be, and sine alpha at the same time it's equal to 1 over 2 x to the power of minus 1 it's going to be. If I get the derivative of both sides, cosine alpha is equal to 1 over 2 x to the power of minus 1, derivative is equal to x to the power of minus 2, but minus here we are going to give this minus 1, minus 2 dx, it's going to be cosine alpha d alpha. Let me rewrite this part again. Cosine alpha d alpha, it's going to be equal to cosine alpha d alpha, it's going to be equal to minus 1 over 2. I couldn't write, sorry for that one. Equal to cosine alpha d alpha, it's going to be equal to minus 1 over 2 x to the power of minus 2 dx. Then here cosine alpha d alpha is equal to minus 1 over 2 1 over x squared dx, but here we have only 1 over x square dx, and we have also minus 2 here. And what we are going to do for this substitution, I think we can do like this. Cosine alpha d alpha it's going to be equal to here minus 1 over 2 times 1 over x times 1 over x dx. I have 1 over x dx here, so I'm going to send the other terms here, other side. But if I write here 1 over x, if I send to other side, on the other side we are going to have the terms with x. This is not possible. Again, I'm returning to our substitution, and I found that 2 sine alpha, normally 2 sine alpha is equal to, 1 over x. So instead of 1 over x, I'm going to write 2 sine alpha. Then I'm going to complete my substitution. It's going to be like this. Cosine alpha d alpha is equal to, cosine alpha d alpha is equal to minus 1 over 2 times 1 over x. It's going to be equal to 2 sine alpha 1 over x dx. Now I'm going to send the alpha terms to the other side. Before than that one, let me simplify this one, and it's going to be equal to minus, this minus sign also, it should go to the other side because we don't have minus sign inside the integral here, only inside the root, but that's going to represent differently. Then it's going to be equal to cosine alpha over minus cosine alpha over sine alpha is equal to 1 over x dx. It's going to be 1 over x dx. So I'm going to write here, maybe I can write this one also, tangent tangent alpha d alpha also we can write here. It's equal to 1 over x dx. Minus tangent alpha d alpha is equal to 1 over x dx it was. So integral of square root of 4x squared minus 1 over instead of over, I'm going to write here 1 over x dx. Instead of square root of 4x squared minus 1, I'm going to use 4x squared minus 1 is the minus 1 over 1 is the adjacent side over opposite side, which is cotangent. Cotangent alpha times minus tangent alpha d alpha 1 over x dx is equal to, it's going to be equal to minus tangent alpha d alpha. It's going to be, so it's going to be equal to minus integral cotangent alpha times tangent alpha d alpha, and cotangent alpha times tangent alpha, it's going to be equal to minus cotangent alpha times tangent alpha, it's going to be equal to 1. So this is equal to minus integral d alpha, and that's equal to minus alpha plus c. That's equal to here alpha chosen as sine alpha is equal to 1 over 2x. It means that it's equal to arcsine, I'm writing here alpha, it should be equal to arcsine 1 over 2x plus c, it must be, so it's equal to minus 1 over minus arcsine 1 over 2x plus c is going to be